Hello everybody, my name is Dr. Sarah Jackson. I'm an assistant professor in the Emergency and Disaster Management program in the Department of Criminology, Criminal Justice, and soon to be Disaster Science. We're going through a name change currently to represent our program. But I'm actually a geographer, so I'm a geographer in a disaster management program in the Criminal Justice Department, and so I'm very interdisciplinary in my approach. And so I thought for my presentation today on my Hurricane Helene, one of the 4 Hurricane Helene related research projects I'm working on, I could visualize it and kind of mix this up in display with what is called a story map. Has anybody ever seen or used a story map before? A few of you. So this is a great way to display geospatial visualizations and tell the story of a research project that is more interactive, place-based. So I'm just going to kind of scroll through as I tell the story about this particular project. So this study was done in collaboration with a wonderful colleague, Leah Blackwood, who is an emergency management analyst at Argonne National Lab and is also an adjunct instructor in our program, as well as with the help of some students from the disaster research group that I founded in our department. So about a couple months after Helene, we were awarded a grant from the NC Collaboratory to investigate across all 300 disaster declared counties throughout the Southeast, all of the large impacts of the data sets that were available at the time, to investigate social vulnerability throughout the study region, and then also look at warnings and warning locations, warning language. So this study is very mixed methods. It is quantitative, it is geospatial, it is qualitative in approach, and it is kind of a test base for what more data do we need to move forward to understand particularly where were the hardest hit places when we overlap and overlay these data layers in GIS and kind of start to look at things geostatistically, so using geospatial statistics. So we all know the background of Hurricane Helene, right? We had over 300 localities that were issued a presidential disaster declaration. So that includes 8 different states throughout the Southeast. But as we know, Western North Carolina was particularly impacted with over half of the fatalities associated with the event in this region. So we really wanted to try to uncover these both physical geography and social geography dynamics throughout the impact area. And we actually partnered with the National Weather Service as our practitioner partner, the local weather forecasting office, Greenville-Spartanburg, which serves all of Western North Carolina, all of upstate South Carolina. So we partnered with the warning coordinator, the meteorologist there, to work with us throughout the project. So every month throughout the year-long study, we would have meetings with them. They would give us feedback on the process, give us data about what's going on, like the flash flood emergencies that they issued from their office. And it was particularly useful because one of the partners at the office, her first day of the job was the day Hurricane Helene hit. And so we wanted to be able to show, right, the National Weather Service is doing an incredible job, and that we need to continue funding public access to warning technologies and communication. So 2 of our research questions for this particular study: how do areas impacted by Hurricane Helene differ based on their urban-rural dynamics and social vulnerabilities? There's a lot of the same things that Izzy was talking about earlier with urban rurality and vulnerability. And then looking at the differences in the warnings and evacuation orders that were issued throughout the study area. So you can see here in this first map, this is all of the 300 disaster declared regions, the path of Hurricane Helene throughout the study region, the variations in wind speed. If you aren't familiar with science of hazards and tropical storms, usually in the northern hemisphere, the upper right quadrant of the storm is the most damaging. And so this right side of the path of the hurricane, and you'll start to see some patterns emerge there once we pull in some additional data. So this is all interactive. You can zoom in on these counties, click and get some basic information about what's going on in this particular county. What is the total population, the households, housing units, what urban-rural designation, what particular disaster declaration they received, and what National Weather Service office locally serves them and provides them warnings. So as far as the data that we analyzed, we pulled in a lot of different federal data sets like the American Community Survey data for our custom social vulnerability index for the study region. We pulled in the urban rural codes from the USDA. We also got aggregated rainfall data for precipitation from the National Weather Service. We had locations of all the landslides that hit throughout the region from the U.S. Geological Survey. We got fatality data from the National Weather Service and the National Hurricane Center directly, and from FEMA's open source website on the types of assistance that were received when each county was declared a disaster, because it wasn't immediate. We had some counties like in West Virginia, they actually didn't get a disaster declaration until December, so a few months later. And so we had to keep kind of going back, rechecking in, re-getting data from FEMA saying how many people have applied for assistance, how many people have been inspected, how many people have been approved, what are these amounts of losses. And then obviously we have our warning data from the National Weather Service specifically, as well as the local public alerts. So there's two types of warnings we looked at. The formal National Weather Service warnings that you get and see, and you can see at the top here are warning in this screenshot, flash flood emergency. And then there are local warnings that are not issued by the National Weather Service. They're issued by local emergency managers that are very variable, and who is qualified to send these alerts, what kind of messaging should be put into these alerts. And so you can see this is a screenshot of my husband's phone actually once we got service 5 days after Helene, when all the warnings started coming in. So it's not necessarily we're looking at whether the warnings and when they came in and what people did, but what the warnings said and if they were intended, and following appropriate theory and science about what should be included in the warning. So essentially, right, we pulled, it says battery savers on the computer, but hopefully I'll make it through the meeting. So we wanted to overlay all of our data sets. Everything is aggregated to the county level because that's the lowest availability for most of these data sets. So we can see first, just looking at rainfall impacts again throughout the study region, we can see the densest rainfall here in western North Carolina, and in throughout kind of central southern Georgia, upstate South Carolina, and then as the storm started to kind of move towards the northwest, we shift over into Tennessee and Kentucky as well. Here is the wind swath, because we know a lot of the fatalities associated from the storm were not just from flash flooding, but from the wind knocking down trees, landing on vehicles, on people, on homes. And so we wanted to make sure we understood where the range in the wind speed was, especially because by the time it got here, right, it had been downgraded to a tropical storm based on that wind speed in comparison to somewhere like Florida, where it made landfall as a hurricane. If you do investigate this later, there is a little tab down at the bottom that kind of tells you what each is an indicator of. In terms of the landslide data, we zoom in here now in western North Carolina and the Appalachian region. We had over 2,200 landslides throughout the study region. So we mapped them both by their point locations, and then we did a statistical heat mapping, which essentially statistically clusters where the densest concentrations are. So you can see I have both of those overlaid here on the map. And what we saw is if you're looking at just landslide counts, how many happened per county, Buncombe was very, very high. But if we normalize these landslides as a number of landslides divided by the land area in square miles, we actually get our rural counties like Ashe, Avery County up north that actually had the densest concentrations of landslides per the land area of the county. In terms of fatalities, this is something that is still protected information, and so we had to aggregate a lot of this data for what was going on. If we look at just the counts, again, raw counts of fatalities, we can see some clusters here throughout central Georgia, upstate South Carolina, and obviously Buncombe County popped out really high there. But obviously these are going to be higher in places that have a higher population. So we wanted to be sure we normalize this data set as a measure of fatalities per capita. And once we do that, the same counties that we saw that had the densest concentrations of landslides once they were normalized also become higher north of Asheville, particularly here in Yancey County, as well as the neighboring counties, Ashe, Avery, and then on the border of Tennessee, where we know we had a lot of very devastating impacts as well. So presenting a totally different pattern, right, when the data set is aggregated or represented as a proportion of the population. This is just showing the different types of disaster declarations that were issued. So disaster declarations don't come standard. We have individual assistance that's provided to individuals and households. They have to go through the assistance process, which takes months. You can only get upwards of max of about $45,000, even if your $400,000 house was taken out. And then we have public assistance, which is issued to public governments for things like public road repair, public structure repair. So really this just indicates what types of assistance different places received. And so we hope to investigate this a little bit more later once we've received in that data, because they're still submitting applications, this stuff is still getting approved. Just some visuals here to kind of bring us from this bird's eye view to looking at what we're talking about here on the ground, especially thinking about impacted areas of Asheville and then north. This is the North Fork River. This pedestrian bridge was taken out. A lot of our critical infrastructure that was damaged. We've got the historic French Broad River Park. This is actually my road the day that they got power back, and we came down and saw the power trucks there. And so we know that critical infrastructure is a huge part of this, and we're hoping to expand and bring in some of these impacts as we get some additional funds to get this data from these private companies about things like power outages and et cetera. So similar to what we saw with Izzy's presentation earlier, we created a custom social vulnerability index for the study region. And so we looked at particularly those according to the SOVI model from the hazards of place dynamic from Dr. Cutter's framework from the University of South Carolina. We found that looking at total social vulnerability, we were highest in many areas of Florida. We have a lot of elderly populations, kind of lower income, dependent on Social Security, which makes a lot of sense. And then if we look at places like Western North Carolina, we see the Native American vulnerable group, the service industry, extractive industry is what is causing our kind of high vulnerability here. And then everywhere you see in white is just kind of this medium vulnerability. They sit somewhere in between. So this is when we're looking at total vulnerability, and this is spread across 7 different factors. And don't have time today to go into each of these factors, but there is additional maps if you keep scrolling there that look at each individual factor. So that first question, right, these vulnerability concentrations, we also wanted to understand these urban-rural dynamics more. And we saw from even normalizing landslides and fatalities that urban rurality was obviously a big indicator of what was going on. So throughout the study region, we have a variety of urban-rural designations, but the majority of counties are actually rural, 57% of the 300 disaster-declared counties throughout the study region. So we look at where landslides occurred in urban or rural places. We can see dense concentrations of landslides. Kind of the height of the spike means more landslides were experienced there. And then the darker of the color means it's a more rural county. So what we see in our kind of most rural darkest, again, Yancey County comes out with very high landslides being very rural, which mirrors the pattern that we observed before. We also have our bivariate map that is showing us areas of urban-rural designations and higher rates of fatalities. So in this kind of burnt, darkest orange color is where you're going to have the most rural counties with the highest rates of fatalities. So we're able to overlay and see both of these at the same time, which again, showing patterns that we've already identified. I'll skip down now to the warnings. There were over 4,700 warnings that were issued by the National Weather Service throughout the study region between the 23rd of September all the way up until we got about October 3rd, because we had many warnings that were continuing to be issued. And so what we saw when looking at these warnings is the highest concentrations, again, we found in our rural Southern Appalachian region. We also saw when we normalized the warnings by population that Buncombe County actually dipped down a little bit there, and by land area. So again, thinking about this size of the county, how many warnings were issued, the patterns that emerge are pretty obvious in the map here. Lastly was the language of these warnings. So compared to those National Weather Service warnings, the local public safety alerts, many of these were evacuation orders, mostly issued by Charlotte-Mecklenburg County in that area. But we saw there were many others issued throughout the state at the time. We had many flash flood emergencies that were issued, and we actually coded about 1,000 words and phrases from these 69 local weather alerts alone using qualitative thematic analysis, and we found that most of these phrases could be grouped into these 4 themes. So we had message structure, we had message emphasis, orders and guidance, and whether or not they're discussing specific hazard risks and impacts. So we're hoping to expand this to look at how that compared to some other similar tropical hazards that came inland. So bringing all this together, we know we've got some clear hot spots, especially in western North Carolina, the panhandle of Florida. We know there were some specific demographics that contributed to this that we've highlighted, and that these rural areas were targeted and had higher rates when things were normalized. And for our evacuation and warning orders, that the National Weather Service were great. They hit all the key warning elements, but our local weather alerts, many of them were missing key elements like what time is this warning for? What location is this warning for? And so local emergency managers need to look to the National Weather Service standard when they're designing and issuing these warnings. But again, there's nothing to say whether we know people are actually getting them and acting on them. So we hope to do that and expand it more a little bit in the future. So thank you to our funders and this extra time I took. And yeah, thank you all so much.